Question number 4 says quadrilateral JKLM is a rectangle. Quick question. What's that word quadrilateral mean? A four-sided shape, a polygon with 4 sides. So we don't have to prove that things are polygons. If we look down and we can count that something has 4 sides, then we know for a fact that it's a quadrilateral. But taking it beyond just quadrilateral into, is it a parallelogram or is it a rectangle, we either have to be told or we have to show that we know that that is true. It says MN is 3x plus 1. So MN would be this right here. That's 3x plus 1. I'm going to scoot that down just a little bit. There we go. And then we have that JL is 2x plus 9. From J all the way over here to L. There's 2x plus 9. Before we go any further in the problem at all, what do we know about the 2 diagonals in a rectangle? They bisect each other. That's true about rectangles and parallelograms. Rectangles have one more feature beyond that, but the bisecting is going to be important for this. What else is true about the diagonals in rectangles? Yes, the 2 diagonals are congruent, so when they bisect each other, it cuts it into 4 equal little parts. That X inside the rectangle is 4 little equal segments. So MN is congruent to NK, is congruent to JN, is congruent to NL. So how many segments as big as MN would it take to fit inside JL? 2. So we can say 2 segments the size of MN equals a segment the size of JL. And now we can substitute in 2 times MN was 3x plus 1. And what was JL again? 2x plus 9. We're going to solve this for x now. One of my x's is inside parentheses. What do I need to do to get rid of those parentheses? We are going to distribute. We're going to distribute this 2 inside the parentheses. So that would give me 6x plus 2 equals 2x plus 9. What do I want to do now to solve this for x? Subtract 2x from both sides. What is 6x minus 2x? 4x. So 4x plus 2 equals 9. And now what? Subtract 2 from both sides. So I get 4x equals 7. And then we divide both sides by 4. You can leave this in fraction form or in decimal form. Fraction form would just be 7 over 4. That's fully reduced. Nothing goes into 7 that also goes into 4. Or we can write this as a decimal. What is 7 divided by 4 on the calculator? 1.75. So your answer for x can be given either way, 7 over 4 or 1.75. Right. Now that we know that, is there anything else down here that we can find using our value for x? Which one can we find? MK. We know that MK is equal to what? JL. MK and JL are the same size. So that means that MK is equal to 2x plus 9. And we just figured out that x is 1.75. So I have 2 times 1.75 plus 9. So how big is MK? 12.5. All right. Still need to find y. Let's go back up to the directions and read a little bit more. The measure of angle JNK is 5y plus 2. JNK would be this angle right here. And this is the angle that we are saying is 5y plus 2 degrees. And then we also know that angle JNM is 3y minus 6 degrees. JNM, so this angle right here is 3y minus 6 degrees. What do you notice about these two angles that I just marked? They're a linear pair. Let's go ahead and write that down. Angle JNK and angle JNM are a linear pair. Which means they add to 180. So the measurement of angle JNK plus the measurement of angle JNM is equal to 180 degrees. JNK, what do we put in for JNK? 5y plus 2. Drop down my plus sign. What do we put in for JNM? 3y minus 6. We're going to set that equal to 180. So now we have some like terms to combine together. 5y and 3y combined to give us what? 8y. And then we have our constants, a positive 2 and a negative 6. What do you get when you combine a positive 2 with a negative 6? How much? Positive 2 and negative 6. Negative 4. So 8y minus 4 equals 180. Then we're going to add 4 to both sides. So 8y equals 184. Then we divide both sides by 8. And what do we get? 23. Y is 23. All right. What do we still need to do? Find the measure of JNK and the measure of JNM. Well, the measure of angle JNK is 5y plus 2. So we're going to take what we just found for y and substitute it in. So we have 5 times 23 plus 2 And we get what? 117. Should we put units with that? Yes, what units? Degrees. We just found an angle. 117 degrees. JNM. The measurement of angle JNM. What did we have for the measurement of angle JNM? 3y minus 6. So the measurement of angle JNM is equal to 3 times 23 minus 6. What is 3 times 23 minus 6? 63. We're going to put degrees with that as well. And what should be true about JNK and JNM? They add up to 180. So when I get to the very end, I can double check that these two numbers add up to 180 to make sure that I did this part right. Do 117 and 63 add to 180? Yes. Wonderful. All right. What questions do we have before we go on and look at number 5? All right. Let's go to number 5. That has to be put away, and it needs to stay put away. Quadrilateral PQRS is a rectangle. You are given that the measure of angle PTS is 40 degrees. Let's add that to the picture. PTS, this angle right here, is 40 degrees. PQ is 12. So this side right here is 12. And PS is 5. So right here is 5. Using just that information, we need to find the measure of angle PTQ, the measure of angle PQT, the measure of angle TRQ, the measurements of PR and TQ. All right. So let's dive in. PTQ. From P to T up to Q. So we're looking for this angle right here. What do we know about that angle and the 40-degree angle right next to it? Makes a straight line, and so that means it has to add to 180. So how would I find this angle then? Yes, we're going to do 180 minus 40, and that'll give us what? 140. So PTQ is 140 degrees. Beautiful. We need PQT. Let's look up here. I'm running out of colors. PQT. That would be this angle right here. What do the diagonals do in a rectangle? What do the diagonals do to each other? They bisect each other. What else is true about the diagonals in a rectangle? Yes, the two diagonals are congruent, so all 4 little segments are congruent. So this is congruent to this, and it's also congruent to this, and it's also congruent to this. So if all 4 of those little segments are congruent, what kind of triangle is this? It's an isosceles triangle. An isosceles triangle has two sides that are the same. What's that mean about the angles? Two of them are the same. We have two angles that are the same. My base angles, the angles that are opposite from my congruent sides, those would be my base angles. I know they're up at the top, but they still get called base angles. All right, so to figure this out, we're going to take the 140 degrees plus the two angles that I don't know, but I know they have to be the same, so plus x. And that all has to add up to how much? 180. So I'm going to combine my like terms. We're going to combine the x's together, and at the same time, I'm going to subtract 140 from both sides. What do we get when we combine x and x together? 2x. What is 180 minus 140? 40. And then we're going to take this and we're going to divide both sides by 2. What is 40 divided by 2? 20. X equals 20 degrees. So this angle is 20 degrees. So I'm going to go ahead and add that to my picture. This is 20, and this is 20. Angle TRQ. TRQ. This angle right down here is the angle that we're looking for now. Do I know how big this angle is? 40 degrees, yes. And so what kind of triangle would this be? It's an isosceles triangle again, so I'm going to solve for angle TRQ the exact same way that I solved for angle PQT. So I know 40 degrees plus my two other angles, y plus y, equals 180. So we're going to combine our like terms. We're going to combine our y's together at the same time that we subtract 40 degrees from both sides. So that would cancel out over here. I would have 2y equals 140 degrees. And so how big is y? 70 degrees, yes. All right. So far, so good on how we're getting here. This relies on you knowing not only the diagonals bisect each other, but that the diagonals are congruent. So inside a rectangle, the four little segments being formed by that x are all congruent to each other, and that makes isosceles triangles. All right, next thing they wanted me to find was PR. And I'm actually going to redraw this rectangle because I feel like I've got too much going on in the picture. All right, so off to the side, I'm redrawing this. So here's P, S, Q, R, and then I need to draw in those diagonals. We know this side is 5, and we know across the top is 12. And we have been asked to find PR. So PR would be this right here. Well, what is this shape right here? A triangle. Specifically, what kind of triangle? Tell me about the four corners of a rectangle. They're all right angles, so this would be a right angle right here, just like it would be a right angle down here. So I have a right triangle. How big is QR? How big is this? 5, because it's the same as the side that it's opposite from. So I have a right triangle where I know 2 of the sides. We just came out of a unit where we talked about how to do this. How do I find the hypotenuse here? A squared plus B squared equals C squared. So we have 12 squared plus 5 squared. Equals PR squared. What is 12 squared? 144. What is 5 squared? 25. Equals PR squared. What do we get when we add 144 and 25 together? 169 equals PR squared. And then how do I get rid of the squared on PR over here? Square root. And if you do it to one side, got to do it to the other side. So the squared and the square root cancel out on the right. What is the square root of 169? 13. Technically, it's positive or negative 13, but I can't have a diagonal that is a negative length. So only the positive answer makes sense here. So this is 13. And then we need TQ. We're looking for this next. What do we know about all 4 of these little half diagonals? They're all the same size. So this is the same as this, is the same as this, is the same as this. So how many segments the size of TQ would fit in PR? 2. 2 segments the size of TQ would fit in segment PR. Do we know how big segment PR is? How big is PR? So 2 times TQ equals 13. So the last thing I need to do is divide both sides by 2. And I get TQ is equal to what? 6.5. Very, very nicely done. All right. We are going to do just a little bit on the next page. By the way, what we just finished up, that last problem, that's everything you need to do the homework that's due on Tuesday, or due on Monday, sorry. Homework's due on Monday. And we have now covered all of the material that you need in order to be able to do that. So we're going to scoot forward. We're going to talk about rhombi and squares. So rhombi first. Does anybody know what a rhombus is? It kind of looks like a squished square. Kind of looks like a parallelogram, but a little bit like not as fat, not as wide. So rhombi is just the plural of rhombus. So this is weird. I'm not sure what the root of the word rhombus is. I don't know exactly which language it comes from. But there's 2 ways to make the plural. You can say rhombi or you can say rhombuses, whichever one you prefer. I went with rhombi on here because it took up less space on the page. But you could also just call them rhombuses if you wanted to talk about the plural here. A rhombus is a parallelogram with all sides congruent. It's a parallelogram with all sides congruent. So when I come down here and I talk about my sides, all four sides are congruent, and because it's a parallelogram, opposite sides are still parallel. So the top, the bottom, the left, and the right are all the same size. The top is parallel to the bottom, and the left is parallel to the right. The diagonals, just like in a parallelogram, are going to bisect each other. And they are perpendicular. They form a right angle. So let's go ahead and draw those diagonals in, connecting opposite corners. This half diagonal is congruent to this half. This half diagonal is congruent to this half. They're not all four congruent. So this is different than a rectangle. But where they touch on the inside is making right angles. I just realized I put the wrong number of markings on my diagonals because I already used a 1 congruence marking. There, let's fix that. All right. And then my angles. Both pairs of opposite angles are congruent and are bisected by the diagonals. So down here, this lower left angle is being cut into 2 congruent pieces, and that's the same as the upper right. That's being cut into 2 congruent pieces. And then the upper left, those 2 halves are the same size. Same thing with the lower right. Those 2 halves are the same size, and they are the same as the upper left. We will do some problems with rhombuses tomorrow. That is where we are going to stop for today, with just getting that information down. Homework over rectangles. We have covered all of the notes that you need for that. We won't be doing any more notes on rectangles, but if you have questions, I'm more than happy to answer questions. That homework is due on Monday, which is also the date of your first skills check for this module. Skills check will be on Monday. Next homework is due on Monday.